Okay guys, I will just briefly explain you the wiring of this whole electronics under the switch wire. So here is the main power supply. These are the two MOSFETs. One is powering the hot end fan and the second one is auxiliary. I will use it for the lights of the enclosure. This one is a 5 volt 5 ampere buck converter that converts the 24 volt into 5 volts so that the Raspberry Pi can be powered. I had the option to power the Raspberry Pi using the direct GPIO pins, but actually the USB one is very safe because it has a fuse and some kind of safety features also inbuilt in that. So I'm just directly powering the Raspberry Pi using the USB cable. Then this is the IC plug, that is the main AC power plug. From here only the AC power goes to the power supply. Then all the 24 volt lines are connected to the main printer main board and the MOSFETs. Also, one thing is that many people will tell that I have not used any kind of cable management or cable raceways over here, because there is not enough space actually, because you can see how clumsy it is under the under 3 frame. You literally have very less place to fit all the components and do the wirings properly. So I just I just went like, oh, it's okay, I will anyway, it will be underside of the printer, so I just did all the cabling without any management and just kept track of which wire is going where, and that helped me out during the wiring of the printer. Also, one thing regarding the wiring of the wires coming from the wire loom of the toolhead PCB, it is very not conventional if you don't have a PCB breakout for that toolhead PCB also. As you can see, I had to do all the connections directly to the main board without a breakout board. So a tip for that is that you have to remember some things like all the thermistors. Okay, the thermistors are kind of a sensor, so that input goes to the thermistor ports positive or the input signal pin, right, not the ground. And when it comes to powering the bed or hot end or the hot end fan or the parts cooling fan, these are connected to a integrated MOSFET in the main board. So while connecting that, the single wire that comes from the toolhead PCB will be connected to the negative of the terminals over here. So remember, for thermistors and input sensors, it gets connected to the positive side of the ports in the printer main board, and for heating element, the heater cartridge, the heated bed, hot end fan, parts cooling fan, or any kind of auxiliary lights or switch, anything, it will be connected to the negative port of the main board, as you can see here. I have still left one thing to source for the electronics, that is, as you can see, this area is empty. This area, it will house a 6020 axial fan, which I have not sourced yet. I will buy it and install it here later in the coming videos. Also, to help out you guys and making easy for you guys, I'll be posting a wiring diagram with proper labeling in my GitHub page of my switchwire, HN switchwire, which I'll be providing the link in the description, so do check it out. And so let's go to the commission of the printer. Okay, so let me show you some calibration prints and some comparison. So first of all, let us see this cube first. Okay, this cube was printed on my original Ender 3 Pro with before the conversion, as you can see, and you can hardly see any ringing in this cube, and the overall finish of the cube is very good. But one thing is that the first layer was not that good. As you can see, it has elephant's foot right here. Next, if we come to our Voron cube, which I printed on the Switchwire after I converted it, as you can see, there is ample amount of ringing on that. The ringing is very visible, and the Z layers are very good. There is no Z banding, as you can see, but there is very amount of ringing, very much amount of ringing on that. And the first layer is also good, as you can see. So what I did, I don't know why I printed this large chunk of cube, maybe to know the amount of ringing that was caused in the printer. So I just printed this big cube. I don't know why I printed this. So anyways, I just moved on to doing first the pressure advance for the printer, and as you can see here, this is the pressure advance tower model. I printed it. As you can see, the sweet spot has been it came really quick in the direct drive setup, as you can see here. If I compare it with the tower when I printed in the Bowden setup when I had my Ender 3 Pro, you can see it is very way up, as you can see here, at least good 20 mm or 25 mm space. But in direct drive, as you can see, the sweet spot comes right in very quickly. So just stop the print if you see these kind of layer artifacts coming right on. Just stop the print, and then after that you can just go on and start calculating the distance, and you can calculate a pressure advance value. So next, then after I went for obviously resonance compensation, or also called as input shaping. As you can see, I tried to print this ringing tower model, and it got fucked up around at least where layer number 200 or something like that. 200. It was my fault actually. The reverse Bowden tube was very tight, and it was pulling the head, so I got layer shifts around this point. But as you can see, the ringing was very prominent, and it is visible in the camera. So I just took the marker and marked some spots of the ringing of the ridges, as you can see here. Then I calculated using a caliper, and in the traditional way I calculated my ringing frequencies of the printer. The one downside of that is that what I've noticed is that my printer is ringing at several frequencies, right? Not one frequency, though, so that is a problem. So that led to this model. As you can see, this one printed properly, but as you can see here, there is no ringing till 4000 or 5000 acceleration. After that, very fade amount of very faded ringing is visible. So the thing is that I did not why I went for this traditional method of doing the resonance compensation is that I killed my Raspberry Pi. Yep, I killed my Raspberry Pi by very rookie mistake, that is shorting the 5 volt and 3.3 volt line. So be careful while doing your wirings. So actually it was the stage when I was trying to figure out the ADXL 345 to connect it with the Pi. Then I accidentally shorted the 3.3 volt rails with the 5 volt rails, and it killed my Pi, which is very bad, to be honest. I just wasted somewhat around $20 to $25 out of my pocket money, which is a very big damage. So the thing is that it does not boot now, and the main thing is that the PMIC chip of the Raspberry Pi is dead, so probably it is not the 3.3 volt is not being given to the required hardware components of the Raspberry Pi, so that's why it's dead. But no problems, as I have my spare Creality Wi-Fi box, as you know already. In my previous videos I use that to print my stuff, so I don't think I will be buying a new Raspberry Pi because I don't have money. But till that I will be using my Creality Wi-Fi box. It is very good actually, no problem in there. But in some in the problem is that you cannot print very at high speeds. Actually, at that time it starts to overload and kills the printer and the clipper goes in a shutdown state, and that's it. But if we can say, after resonance compensation, if we see here, yeah, the cube which I tried to print came out very good with pressure advance tuned and what we can say, like resonance compensation input shaper tuned. As you can see, the cube came out very well, but the problem is that again a little bit of ringing was visible in the external parameters, as you can see. So what I did is I lowered I found a sweet spot such that the ringing was very little, and finally this is the final cube. I marked it F, lol. So the top layers are good, the edges are very sharp, there is almost no ringing in the cube. The first layer is awesome, no elephant's foot, and the overhangs, as you can see, are very clean. So I think I have properly tuned my printer now. So after this we will be going to build the enclosure for a printer to print ABS. So let's go do that. See you in the next one.